Hello, my name is Professor John Maisonneuve. I'm an assistant professor in mechanical engineering here at Oakland University. Today I'm in the fluid mechanics lab, which is in room 360 of the engineering center. And I'll be introducing you to some of the equipment and some of the tests that we run in this lab. The lab is used throughout the year by students at both the undergrad and grad levels. There are two primary courses that use this room. One of those is ME 3500, Intro to Fluid and Thermal Energy Transport. And at the senior level, we have ME 4510, which is Intermediate Fluid Mechanics. Altogether, with those two courses, that's about 90 students per semester that will be in this room. I'm standing here with the Brookfield viscometer. We have a viscometer here coupled with a thermo control water bath. And this experiment requires students to get a feeling for the properties of the density and viscosity of fluids. Understand also how viscosity changes with temperature. The way this experiment is set up is we will give the students mystery oil, and they're required to identify it by its viscosity versus temperature profile, which gives like a fingerprint to the fluid. The equipment consists of a viscometer, which students will use to measure the torque versus speed relationship. You can see there's a spindle or rotor that turns inside a cylinder which is filled with the target fluid. And so this instrument will allow students to take a reading of torque and speed. It actually gives them the viscosity from there. We require them to go ahead and work out the viscosity manually based on the torque and speed measurements. So they get a good understanding of how force and movement are related through this property, which is called viscosity. They can regulate the temperature of the fluid. You can see this cylinder is supplied with a working fluid, which is simply water. The water is heated by the bath with a control, and that is circulated around the target fluid in basically a jacket. I'm here with next to the Armfield hydraulics bench. This is a bench that's used for a number of experiments in the fluid mechanics lab, including the fluid in plate experiment. So we have on the hydraulics bench, we have the fluid in plate unit set up right now, and we use this to demonstrate the conservation of momentum. Students are introduced in the class to the integral equation of conservation of momentum. And here in the lab, they're asked to consider a system, being a plate, and how the momentum that is carried to the system translates to a force. And the way the momentum is expressed is by looking at a jet. You'll see a jet supplied by this unit up through this column is supplied to the plate, strikes the plate. The momentum can be observed and measured by recording the flow rate, or the rate of the fluid motion. The force that is related to that can be observed and measured by recording the force, the mass times gravity, that's required to counteract the force applied by the jet. So this is the hydraulics bench. Let's go over and take a look at the wind tunnel, which is used in the intermediate fluid mechanics course. I'm standing next to the Armfield wind tunnel. This is a wind tunnel that's used in the intermediate fluid mechanics course, which is cross-listed at the undergrad, grad level. And in that course, students are introduced to an intermediate and advanced fluid mechanics. The wind tunnel is used as well as a number of other pieces of equipment, including various turbo machines such as compressors, pumps, turbines, and other equipment is also used, including the friction measurement bench. Now we can have a look at the safety features of the lab. The EC360 Fluids Lab is a secure lab which only offers access to students that are registered. They require keycard access to enter the lab, and the lab is equipped with several safety features and equipments. That includes emergency eye wash stations. It includes overhead shower. includes a fire extinguisher, safety glasses, which the students are required to wear when working with compressed air or high-pressure fluids, and finally a emergency procedures booklet that is located next to the entrance of the lab. The lab is also equipped with 2 doors for emergency exit.